Hello, buenos dias. Welcome to today's Math is Everywhere topic of the day. We're in Unit 7, and our second video for Unit 7 is going to talk about the substitution method. This is a method that you can use to solve systems of equations, and it's called the substitution method because we're going to use substitution to help us solve the equations. What does that mean? Well, let's take a look at some examples. Okay, so we're going to use three different methods in Unit 7. The substitution method is just the first of the three different methods. Remember, solving a system of equations means to find the values of x and y that make both equations true. It's like solving an equation, but instead of just solving for x, or just solving for y, you have to solve for both. And instead of just having one equation, you're going to have two equations, like this. The sum of two numbers is 40, and their difference is 4. Find the two numbers. Let's reread that. The sum of two numbers is 40. X plus y equals 40. That's a sum, and it is 40. Their difference means subtraction, is 4. So this is really a system of equations. It was just disguised as a word problem. We have two equations here, x plus y equals 40 and x minus y equals 4. And we're going to solve this system of equations, and we're going to figure out exactly what x equals and exactly what y equals. And it's going to work, our solution's going to work for both of those two equations. Now, if I'm just dealing with this first equation, I know a whole bunch of numbers that add up to 40, like 20 and 20 add up to 40. Okay, or maybe it's 10 and 30 add up to 40. Or who knows, maybe it's 1 and 39. But we don't know if any of those is the actual solution because those two numbers also have to work here for this equation. Speaking of this equation, notice on this equation you have a minus sign, x minus y. Well, if this y right here was a number like x minus 5, wouldn't you just try to get x by itself by adding that to both sides? Remember how we did that before when we were solving equations? We got x by itself by doing inverse operations, and the inverse of minus y is plus y, and the inverses cancel out because minus y and plus y cancel out. So now on the left side of the equation we just have x, and on the right side of the equation we have 4 plus y. But you can't combine a 4 and a y, so we're just going to leave it as 4 plus y. Great. What did we really accomplish there? Nothing really, except that if we know now that x equals 4 plus y, I could take this x over here and I could plug 4 plus y right there. Because if x equals 4 plus y, then I could take 4 plus y and substitute it wherever there's an x. That's why this is called the substitution method, because we're going to take this x here and we're going to substitute 4 plus y where that x is. When I do that, instead of x plus y equals 40, I'm going to have 4 plus y plus y equals 40. I'm trying to do this slow enough that you can kind of follow along with what I'm saying. So, just to make sure, this y came down here, the equal sign came down here, and the 40 came down here. All of that was the same from this equation to the next. But this 4 plus y came from here. And the reason that I changed this x into a 4 plus y is because over here we said that x equals 4 plus y. Okay, so now we have 4 plus y equals 40. I got rid of all that other junk so that we could just focus on that. Now we can solve this equation because guess what? Now I have y plus y, which is 2y, and now I have 4 plus 2y equals 40, and this is an equation that you can solve. It's just a simple equation with one variable. That one variable is this y right here, and we're going to have to get that y by itself. So we're going to have to get rid of the 2, but first we have to get rid of the 4. Remember that? So to get rid of the 4, I'm going to do minus 4, because 4 minus 4 cancels. And I did that on the left side of the equation. So to balance, I've got to do a minus 4 on the right. Hopefully you remember this process of solving equations. Now I've got to get rid of that 2, so I've got to do the opposite of 2 times y, multiplying by 2. The opposite of that is dividing by 2. So I'm going to divide by 2. Those are going to cancel. And finally, I'm going to have y equals 36 divided by 2, which is 18. That's great. But the problem asked us to find the 2 numbers. Well, I found one of the 2 numbers. I found y. Now, I need to find x. Remember, this is called the substitution method, so guess what I'm going to do? If y equals 18, then I can put an 18 right here. So now, this whole equation is going to be x minus y, but we said y is 18, so I'm going to put an 18 here equals 4. And now all I have to do is solve this equation for x. So, what's the opposite of minus 18? Plus 18. That cancels, leaves x by itself on the left, but if I added 18 to the left, I've got to add 18 to the right, and 4 plus 18 is 22. Now, I have a solution to my system of equations. I have x equals 22 and y equals 18. And I can go through and I can check those solutions with my original equations to see if they work. So, let's check them. I said y equals 18, right? And x equals 22, right? Is 22 plus 18 going to equal 40? Yep. Check. I said x equals 22, right? And I said y equals 18, right? Does 22 minus 18 equal 4? Yes. So what's my solution to this? My solution is x is 22, y is 18. That is the solution to this system of equations. Let's try another one. That one was a long process, right? So let's see if we can do this one a little bit quicker. This one is actually going to be easier because it already tells us that y equals 2x minus 2. So I can just take this y and substitute the 2x plus 2 where there's a y. So that means this x is still going to be an x, plus, instead of y, I'm going to put 2x plus 2. Hopefully that makes sense. It's called the substitution property, or the substitution method, because I'm taking this y and plugging in this for that. Now, the point of that, the reason why I did that, is because now we only have one variable, and it's x. And that makes this easier to solve. Because now this is a simple two-step equation, and I can just, whoops, not that, right? Hopefully you're following along with these steps. And I've got half my solution there. I know what x equals. X equals 5. The other half of my solution is I need to figure out what y equals. Well, how am I going to do that? The substitution method. I know that x equals 5 now. So, if x equals 5, I can take this equation and say y equals 2 times x, which is 5, right? We said x equals 5, plus 2. Now this is really simple because 2 times 5 is 10, and 10 plus 2 is 12, so y equals 12. So my solution ended up being 12 here, and that works because if we have x equals 5 and y equals 12, is 5 plus 12 17? Yep. And is 12 equal to 2 times 5 plus 2? Yep, because 2 times 5 is 10, plus 2 is 12. So our solution is x equals 5 and y equals 12. Or, remember the other way we can write that is 5 comma 12, because we put x comma y. And that is our solution to this system of equations. Okay, remember this is all about solving a system of equations. Taking two equations, working together to figure out what x equals and what y equals so that it works for this equation and that equation. And the substitution method is one method that you can use to solve a system of equations. Woo! A lot of work. Should we try one more? Okay, this one's a hard one. Okay, I'm going to try to do my best on this one, but the problem here is in order to substitute, I've got to have an x by itself or a y by itself. So I've got to get one of those x's or y's by itself so that I can plug it in for the other x or y. But this x isn't by itself, and this y is not by itself, and this x isn't by itself, and this y is not by itself. So how do I get them by themselves? Well, let's look at this one. If I wanted to get that x by itself, I'd have to get rid of the 3, and I'd have to get rid of the plus 4y. But if I wanted to get this x by itself, all I would have to get rid of is the plus 2y. This x is going to be easier to get by itself than any of the other parts. So I'm going to get that x by itself, and the way I'm going to do it is the opposite of plus 2y is minus 2y. Now I have x by itself. But if I subtracted 2y from the left, I've got to subtract 2y from the right. You can't do 10 minus 2y. They're unlike terms. So I just have to say x equals 10 minus 2y. Here's where it gets a little weird, because I have to take this whole quantity, okay? I have to take this whole quantity right here and plug it in for x right here. And since that x is getting multiplied by 3, I have to take this whole quantity and multiply it by 3. So it's going to look like this. 3 times 10 minus 2y plus 4y equals 8. Okay, again, just so you see that, this came from this. This came from this. This came from this. And this came from this. Okay? Now let's solve it. Whenever you've got parentheses, we've got to distribute, right? 3 times 10 is 30. 3 times 2y is 6y. And since there was a minus there, I'm going to just keep that minus there. There's also a 4y over here, and an equals 8 right there. Now what you might see is that there's a minus 6y and a plus 4y. That's a negative 6 and a positive 4. That means you have negative 2y. How am I going to solve this? I've got to try to get this y by itself, right? So I've got to get rid of this 2, but before I do that, I've got to get rid of this 30. How do I get rid of a positive 30? 30 minus 30 cancels out. But I've got to do that on the other side as well. What do I have left over? I have a minus 2y and an equals, and then an 8 minus 30, which gives me negative 22. Try that on your calculator if you need to. And then I can just divide by negative 2, divide by negative 2. These should cancel, and I'll get y. Negative 22 divided by negative 2 should be positive 11, and I'm halfway done with my solution to this system of equations. Thankfully, that was the difficult half. The rest is, I need to find out what x equals. I can do that by taking 11 and plugging it in for y. Okay, now let's take a look at this equation and what it originally looked like before I did all that crazy junk. Okay, there we go. I took this 11, since y equals 11, and I plugged it in right here. So instead of an x plus 2y, it's going to be x plus 2 times 11 equals 10. Now all I have to do is 2 times 11, which is 22. And now I just have to solve that equation. The opposite of plus 22 is minus 22. These cancel, and I get x equals 10 minus 22. 10 minus 22. That should come out to, negative 12. Make sense? So my solution is x equals negative 12, y equals 11, and I just solved this system of equations. My solution is negative 12 comma 11 for x and for y. That was a tricky one, and if you understood this third example problem, you're amazing, because this can get pretty tough. It can take up a lot of paper, but it's worth it because now we definitely know what x equals and we definitely know what y equals. Alright, thanks for being patient and making your way through this video. I want you to try a practice problem now. This is x plus y equals 66, and x minus y is 34. What you're going to do is you're going to substitute, but before you substitute, my suggestion is that you get this x by itself by adding y to both sides, which would give you 34 plus y equals x. And if x equals 34 plus y, you can plug 34 plus y right here and then solve this equation. And eventually you'll know what y equals and you'll know what x equals. Try it. And if you're still a little confused on this, we'll work on it some more tomorrow. All right. Good job, everybody. Way to be patient. Way to persevere. I'm proud of you.